let's look at a special right triangle, 30, 60, 90. And what I want to do here is establish the relationship among these three sides, so the hypotenuse, the short length, and the long length here for these sides, and be able to do that so that later on when I see a 30, 60, 90 triangle, I can use those relationships to solve for a missing side rather than reverting back to the Pythagorean theorem, although we will use the Pythagorean theorem to establish these relationships. All right, let's call this short side length x, okay? If I do that, now I'm tasked with finding these other two side lengths. So how could I do that? Well, one way I could think about that would be to draw an equilateral triangle. That means all the sides are the same, and draw in the given triangle, which would be the top half of it. So let's say this is 30, this is 60, and this is x here, which is just this length. Okay. Well, if I reflected that triangle down to make this other triangle, this is a little wonky, but you get the idea, then I would have this interior angle be in 90 degrees, reflected 60 degrees, and the reflected 30 degrees. So then if I have that, I now have this equilateral triangle. So I can think about what kind of some of the missing sides would be. Well, this would be x down here. So then this whole thing is 2x. Now if that's 2x, then every side of this equilateral triangle is also 2x. So this is 2x, which goes back to my original triangle. So now I have 2x for that. Now I'm not going to be able to use an equilateral triangle for my final side, but I can call it b and use Pythagorean theorem to solve for it. So I'm going to get x squared plus b squared equals the quantity 2x all squared. So again, I am this triangle here. I'm trying to find the value of b in terms of x, and so I'm using those other two sides. So I have x squared plus b squared equals 2x all squared, gives me x squared plus b squared equals 4x all squared. B squared equals 3x squared. B is the positive square root of 3x squared, and b is root 3x, or x root 3. So b is root 3x. So now I see these relationships among these three sides, and I'm able to apply that going forward. So example, find the exact value of each unknown side in the triangle below. Simplify values completely, include units. Rationalize any denominators if necessary. So here I'm given a 30, 60, 90 degree triangle where one of the short sides is labeled 8 centimeters. So how can I solve for these other two missing sides? Well, I can use the relationships that I developed above. I know that I can get from the short side to the hypotenuse just by multiplying by 2. So this value c, if I want to call it that, for the hypotenuse would be the short side times 2, which is 16. And this is centimeters because the original unit is centimeters. And then to go the other way, say I want to solve for b, well here, b is going to be the short side multiply by root 3. So think about what we did up here. We took x and we multiplied by root 3 to get root 3x, and that's how those are related. So it should be root 3 times bigger. So 8 root 3 centimeters for this long side length here.